Okay, so I wanted to walk through a separate example with you for finding variance and standard deviation. Same thing we just went through in your notes. However, I want to look at how the calculations change when you're not dealing with a population where you have everything. Instead, you're only dealing with a sample data set, right, where you only have a subset of the complete population. Now, a lot of the steps are going to be very, very similar, and I mentioned that to you in the video with your notes. So I want to go back and look at what we just did here to calculate the variance, that was here, and the standard deviation for a population data set where these were all of the salaries of interest. All right, now we have our formulas defined on the previous page. We calculated what we call deviation squared in our table, and then we took the sum of squares divided by n to get the variance, and then square root to get the standard deviation. When we're dealing with a sample data set, all right, you'll see those formulas defined right here. You're going to have very, very similar steps. The only real difference in calculation will be instead of dividing by n, you'll divide by n minus 1. Now, there are some other differences just in terms of notation. For example, the mean is x bar for a sample instead of mu. But as far as your actual calculation, the only real change will be in dividing by n minus 1 to get your sample variance. All right, so let's come back over here. We know we're going to need to find sample variance and standard deviation. So what I'm going to do first is just come over here to the side. Make sure that I have the formula that I'm going to need. Whoops. Which first, before we get to standard deviation, will be the formula for sample variance. All right, and this is in your notes. We just looked at it. It says S squared is the sample variance. We calculate those same deviations squared, right? X bar just means it's a sample mean. We take the sum, but then we divide that sum by n minus 1 because we're dealing with a sample and not a population. All right, so to get us started, this is going to look just the same as what we did before. All right, we're going to set up 3 columns of work here. We're going to have our x's. We're going to do our deviations. And then we're going to do our deviations squared. Okay, just like what we did in the previous problem. Now remember, to get your deviations, you have to first calculate your mean. For a population, that was labeled mu. For a sample, that's labeled x bar. All right, but we know now that our mean is just the average of the values, whether it's a population or a sample. So I'm going to add up the data values that I have here. I get a sum of 130.8. And I'm going to divide that by 6 because I have 6 values in this sample data set. All right, and that's going to give me a mean of 21.8. All right, that's the value right here that I'm going to be subtracting from each value of x. All right, so I'm going to fill in my table now. I want you to do the same thing on your end. All right, for this first column, you're just going to list each one of the 6 data values. In the middle column, you're going to take each value and just subtract its mean of 21.8, right? So literally, I just took 17, the first value, subtracted 21.8 in my calculator, and I got negative 4.8. And then while I'm here, I'm going to go ahead and square that. So since it's stored in my calculator, and that's the value that goes here in the last column. Okay, so I did this to get the deviation, then I squared it in my calculator, and I got 23.04. Okay, so I'm going to do that for every value. Take 10.7, subtract the mean, and square it. Same thing with 38.7. Subtract that same mean of 21.8 and square it. Almost there. Last value is 15.9. Subtract that mean of 21.8. That gives me a deviation. Then I'll square it and report that here. And remember, everything in your third column should be positive. When you square a negative number, it always turns positive. So at this point, we take the sum of our squares. And again, you should be adding up all positive values. All right, so let's take the sum. I'm getting a sum here of 601.92. Now, what you need to understand, understanding the notation in the formula, is that this sum you just took notationally is the sum of the deviations squared. That means you just calculated this entire number right here in your numerator, just like we did for a population, okay? Up to this point, the steps are exactly the same. Looks a little different notationally, but no change in the steps. So to get my sample variance, I'm going to take that sum, 601.92, but here's the change. For a sample data set, right, which is what we have here, I'm not going to divide by n, the number of values. That'd be 6 here. I'm going to divide by n minus 1. So because this is a sample, if it were a population, I would divide by 6, just like we did in our notes. But because this is a sample, I'm going to take that sum of squares. I'm going to divide by n minus 1. And I'm going to report my sample variance as 120.384. And you guys know MyLab will tell you how it wants you to round, so just be careful about that. All right, so the only change in the work there is that n minus 1. To go from there to our standard deviation, just like we did for a population, once we get our variance, which is a value of s squared, all we have to do to get standard deviation is take the square root of our variance. And then, of course, round it accordingly to what MyLab is asking, but take the square root of that variance. I'm going to round to 2 decimal places, and that standard deviation would be 10.97. The units on standard deviation are the same as the original data. So this is a standard deviation of 10.7 thousandths of dollars. That means the salaries are going to vary by about $10.9 thousand above the mean as well as below the mean. So same interpretation, same basic setup that you're walking through. You just have to remember, if you're dealing with a sample data set, when you go to get that variance, you divide by n minus 1 instead of n. Now, I also wanted to bring your attention to two things that I posted for you in D2L, right along with your notes for this section. And these are their worksheets. You can print these out and use them to help you as you're doing your homework. I will not allow you to have these on your test because I will expect you to show your own work on your test. All right, so know that. But use these as you're doing your homework. And while you're doing your homework, that'll make sure it's setting you up for doing this correctly on your test. All right, so it's kind of up to you if you want to use these worksheets or not. But I would encourage you to use them at least in the beginning to make sure that you are showing all of the steps correctly. And then that way, when you see this on a test and it says make sure you show your work, you're going to know exactly what steps I'm looking for in the work that you're laying out on your own paper.